Alright guys, here we are today. We're now going to use greatest common factor, and I know we spent a lot of time working on those sheets last night for homework, but that's really going to help you in this greatest common factor sheet that we're going to do today. First of all, let's talk about what greatest common factor is. A common factor, so just a common factor, is a number that is a factor of two or more non-zero whole numbers. That makes it common. So if it's in, like 2, for example, is a factor in 6 and it's a factor in 8. That makes 2 a common factor of 6 and 8. Today we're going to be focusing on the greatest common factor. The greatest common factor, or GCF, as I've used right here, GCF, is the greatest of the common factors. So you would look at all the factors that are common between 2 or more numbers, and you would find the greatest of that one. If there's 2 numbers, it just has to be the greatest between the 2. If there's 3 numbers, it has to be the greatest between all 3. So sometimes if you have 3 numbers, there might be a number greater between 2 of them, but it's not included in the third. That doesn't count. It has to be the number that's the greatest in all 3. So let's go over our first example here, which is the listing method. I'm going to scroll down here a little bit. The listing method is something I'm going to teach you guys. It's quick and it's easy to use, but with the sheets we made the other night, you're going to not really use the listing method too many for your problems. So first thing I'm going to do is list the factors of 24, and I'm going to use a table to list them. So I'm going to do 1 times 24, and then that's 2 times 12, and 3 times 8, and 4 times 6. So those are my listed. I listed on 1, 2, 3, 4, 6, 8, 12. Oops, sorry about that. And then I am going to go do the same thing for 18. So that's 1 and 18, 1 times 18, 2 times 9, 3 times 6. Okay, so 1, 2, 3, 6, 9, 18, and then 30. That's 1 times 30, 2 times 15, 3 times 10, no 4, 5 times 6. So that's 1, 2, 3, 5, 6, 10, 15, 30. Those are my factors of 30. So now I have my factors, and I'm going to find the greatest one that I have. So I'm going to look and see which number they all have. Well, they all have a 1, they all have a 2, they all have a 3, 4, no 4 there, they all have a 6, and 8, no 8, 12, no 12, 24, okay, so of all of them, 6 was the greatest. So my greatest common factor, my GCF, is 6. Okay, and that's how you do that. That's the listing method. Okay, I'm going to move on to the next slide if you need to pause. In our next slide, we're going to use our prime factorization, and these are where those sheets that we did, the trees, the factor trees, you want to use that sheet. You don't have to do factor trees for these anymore. You use your sheet as your factor trees so that you can easily answer these. So if I want to find the GCF, remember this whole lesson is on GCF, so I'm finding the greatest common factor of 16, 32, and 40 using prime factorization. To do that, all I'm going to do for each number is write its prime factorization. So when you look up 16, you should have 2 times 2 times 2 times 2. I'm going to look up 32. And I'm going to have 2 times 2 times 2 times 2 times 2. Okay? Then I look up 40. And for 40, I have 2 times 2 times 2 times 5. Okay? And that's what I have. Now you're going to look at this and say, well, the greatest number I have in common is 2. Is that my GCF? No, 2 is not my GCF. What I'm going to do with these now, guys, is I'm going to look to see what is in common in all of my numbers. They have 1, 2 in common, so I'm going to do a 2. They have a second 2 in common, so I'm going to multiply by a second 2. They have a third 2 in common, so I'm going to multiply by a third 2. They have nothing else in common. I do have a 2 common between the 16 and 32, but I don't have anything else. I cannot use just the 2's from the 32. It has to be 1 from each number. So that's all they have in common is 3 2's. One set of 2's, a second set of 2's, and a third set. I multiply that. 2 times 2 times 2 is 8. And my GCF of 16, 32, and 40 is 8. Okay? And it's actually a relatively quick process since you already have all of the prime factorizations done to 100. And that's your answer. Okay, 2 times 2 times 2 equals 8. 8 is my GCF. And that's how you do that using your prime factorization. Okay, I'm going to move on to my next slide if you need to pause. Now we're going to talk about relatively prime. Prime numbers are numbers that only have 2 factors, one in themselves. Well, relatively prime numbers are numbers, it could be 2 or 3 numbers, depends on how many I'm using in my problem, that have a GCF of 1. It is possible for numbers to have a GCF of 1. Now with prime factorization, you have to be careful because the 1s are not listed. You always have to know 1 goes into every number, so 1 is always a common factor. We're working with whole numbers, so that will always be a common factor. So for this one, I'm just going to do the same thing, my prime factorization. So for 39, I write down what I have, 3 times 13. For 50, I'm going to write 2 times 5 times 5. And I'm not using exponents for this. I know that you might have your answers in exponents, but you want to write them without exponents. You want to write them all the way out. So don't write 2 times 5 squared. You want to write 2 times 5 times 5. So it's a little harder to do otherwise. So then I'm looking. They have nothing in common. So I don't say my answer is no GCF. Oh, they don't have a GCF. Look, they have nothing in common. Remember, they always have the number 1 in common. So in this case, this would be a GCF of 1. Oops. So they have a GCF of 1, okay, and this makes them relatively prime. So 39 and 50 are relatively prime, okay? They only have the GCF of 1. That's the only number they have common between them, so they are called relatively prime. 39 and 50 are not prime numbers, but 39 and 50, when I'm looking for the greatest common factor, they're considered relatively prime numbers because when you do the GCF of 39 and 50, it is 1. So together, they are relatively prime. Okay, so that's what relatively prime means. Okay, I'm going to move on. If you need to pause, go ahead. Otherwise, here's our last slide. In our last slide, we're going to be working with monomials. Okay, which means I'm adding in the exponents into this. So what I'm going to do is I'm going to list these out. So I'm going to list out 18xy squared. And again, no exponents, so I'm going to factor it out. So 18 is going to be 2 times 3 times 3 times x times y times y. 28x squared y squared, I'm going to write that out. It's going to be 2 times 2 times 7 times x times y. By the way, guys, with prime factorization, you can always check your work by multiplying 2 times 2 is 4, times 7 is 28, 2 times 3 is 6, times 3 is 18. You can always check your work. You want to make sure just by multiplying the numbers out. Okay, now I'm going to look for, I have a y squared here. I need to make sure I have both my y's there, so make sure you have them both there. Okay, now I'm going to go look to see what they have in common. They have a 2 in common. No 3s, 2s, and 7s. None of them are common. I can't circle the 3s. I have 2 of them, but they're both the same number. It has to be 1 for each number. Okay, look down here. We have x in common. 2x. I have 1 y in common. Times y. I have a second y in common. Times y. So there it is. I multiply all that. Now I'm going to use exponents in my final answer. 2xy squared. And I don't put a multiplication symbol between my variables and my numbers. I can when I'm working, but as a final answer, we don't write it. 2xy squared. That is the GCF of 18xy squared and 28x squared y squared. Okay? That concludes our lesson for tonight. I hope you guys have a great night, and we'll work on these tomorrow in class.